tell you all about bioprinting and then especially about the cassette they are going to make to have a good holder for the different filaments. So, take it away.
Okay, thanks. Hello everybody, and enjoy your meals. If I'm not clear enough, just wave in the back and I'll speak up. My name is Douwe, and I'm going to tell you something about a project that I'm volunteering here for 1 day a week, while I'm trying to convert an Ultimaker to a bioprinting tool as well, which is a project started by Jelle, who is a lab manager here. So, what is bioprinting? This is a scientific definition where bioprinting is defined as using material transfer processes like printing or lithography, for example, for patterning and assembling material that is biologically relevant. It can be cells, can be molecules, tissues, or bioplastics, with a prescribed organization, so in a defined structure, to accomplish one or more biological functions. So we want to have most of the bioprinting stuff is aimed at getting things done mainly for patients, but also for research. So at the moment it's rather a scientific endeavor. You might have heard in the news when things pop up, like lately, I think a few weeks ago at UPenn and MIT, there was a big fuzz about those two groups printing scaffolds, 3D scaffolds that are used to make blood vessels or liver cells. Recently at the Fraunhofer Institute, there was a group that made a template of like biomaterial to which they can make blood vessels attach to and grow. At Washington State University, there people have developed a bone-like powder that can be used, for instance, as hip transplants, or instead of like the titanium stuff. And there's a lot of cool stuff going on. There's a lot of companies that are starting to build machines equipped for bioprinting. The largest of which is Organovo, which has the bioprinter. And Vigitech sells the bioplotter, and Siseng sells the bioscaffolder. So all of them biological tools for biological rapid manufacturing. And the solutions that they're aiming for at the moment are either printing scaffolds or bone prototypes for implants or prostheses, but also aiming to print tissues or organs that can be used to bring into patients. And there's another company, it's called Modern Meadow, that tries to print meat. So you can print hamburgers instead of raising cows or pigs, just using cells to print your the food that you're eating. So what we're working on is we try to make a 3D printing setup so we can print bone or cartilage, which is a kraakbeen in Dutch, which includes cells. So not only the plastic or the material that supports it, but also we want to have a tool that prints actual biological material in it. So that is our ambition. In points, we want to print biomedically relevant objects like bone, fast, accurate and cheap. Ultimaker printers are not thousands of euros, they're like 2,000 euros. The other printers that you saw here are like in tens or hundreds of thousands of euros. We want to not only use PLA or one plastic, but we want to print different types of materials and different materials. So not only plastics, but also, for instance, cells or gels. And it would be nice if our bioprinter is applicable to other sciences as well, or can be applied to other sciences as well. So we chose the Ultimaker for a number of reasons. One, it's a rapid prototyping platform. It's easy to add stuff, to modify stuff, especially here with all the tools and equipment available in the lab. There's extensive knowledge within Protospace because the Ultimaker was developed or designed in part or fully here. I'm not really sure about the actual history, but and a third thing which is really helpful to us, it's accessible hardware and software. The templates are on the internet. A lot of the code, like the firmware, is open source or it's accessible instead of closed source from some of the other manufacturers. So there's a lot of good things that we can build upon. when we started the project, we found that Ultimaker is really good for some things, but for the purposes that we want to use it for, we need to modify a lot of stuff. And we need to modify it both on the hardware side and on the software side. I'm not listing everything here, but for instance, we have to make sure that we're not only printing PLA or ABS, but also support other materials like gels or like syringes. Instead of printing at 200 degrees Celsius, we need to print at biological temperatures, like 30 to 37 degrees centigrade. And we have to make sure that the plastic that is put there at 200 degrees is not burning out the cells that are plotted. We want to use syringes where the cells or biological material can be stored in. It has to be sterile, it has to be multifunctional. That's all the hardware side. And on the software side, there's other stuff that we need to do or needed to do. If you print with multiple materials, you need to have multiple G codes because each of the extruders have to be get their own signal. So we've been working on that, and then Veen, who also has a facility to merge two G codes. We would like to see it for 4 or even more. But porosity of materials. If you print a vase, you want to have it closed. But if you want biological material, you want pores, you want holes, and you want to have them controlled, finely controlled. You can do this software based. We're working on adapting the firmware to suit our needs, and also to integrate with medical data. It would be nice to have like a 3D scan of a jaw or of some hip, and use that information to directly print what we want. So there's a lot of interaction with the hardware and the software that we gave on our project. And the current Ultimaker extruder head, because that's what the topic is focusing on, because Harma asked me to talk specifically about the printing head, extruder head, is the Ultimaker is really well designed for this, because it moves really rapidly, really fast. It's all because all the engine control, like the motor, stepper motor, is not placed on the head, but outside the head. So it's really a lightweight design. And the case is really well optimized for hot end extrusion, as now, for the PLA extrusion. But the drawback is that if you want to do something else with this printer head, it's really hard to modify, really hard to extend, because you have to break open the whole Ultimaker, modify it, and then put it all back, which is a bit tedious and can be annoying. So what we did in our project, instead of having this fixed extruder head, we switched to a new paradigm, which we call the frame cassette paradigm. What we have is we built some sort of a frame, which basically controls the X and Y movement, and also holds what we call the cassettes, or the places where the actual print functionality is put on. So instead of one print head, we now have a slightly larger print head with cassettes that you can connect or disconnect. That's all text. We had a lot of prototypes and a lot of ideas about how to build this extruder head. And just to give you a general idea, we tried a lot of different approaches. And we started first with amending or extending the existing extruder head by, for example, so this is the original plate. This is the aluminum plate or the wooden plate that you have in your regular Ultimaker extruder. And this is the side. So you can see it's really small. We tried to make it larger and put the extruder holes where the PLA goes into. We put them outside of the sides. It didn't work that well because we still had to break down the Ultimaker when we want to modify stuff. So and then we had our first version of the frame cassette model where we made a cross, and on every of those 4 places we can add a cassette to put our printing material. And now we have version 2, which is not somewhere across, but it's more like a rectangular shape. And we hope, with perhaps also input from you guys, to get to a version 3 or 4 to make it even better. So version 1 has been put on Thingiverse. It's thing 25836, so you can look it up on the internet with the description and all the building patterns, the STL files, and the other files to build the cassette system. Version 2 will go up to Thingiverse, I guess, next week or so, because we have to type. Maybe tonight, but we have to type a little story. So this is version 1, and it's a render of how this works. Basically, this is the cross where the 2 axes are controlled. This is the frame, and here are 3 cassettes that are placed to this frame by 2 screws on the side. So it's fully made from plywood on the laser cutter. So regular 4 and 6 millimeter plywood, and it's height adjustable by side screws, regular screws. And this is the rendering, and here is the picture, the live picture. So this is the frame with the 2 axes, and here you can see a M3 bolt, M3 screw that you can connect the cassette to the frame. So the difficulty with this is that if you adjust the screw, then the height goes up and down by about 1 or 2 millimeters, which is way too much because we want to work in the sub-millimeter range of adjusting the height. So because the screws didn't work that well, we started to think about a version 2, which is basically a frame, again of plywood, but now also based on the suggestion from Siert, from Ultimaker, to use PLA to print our own components from plastics instead of using wood. And then instead of using the side, we wanted to use the top to have a screw on the top to adjust the height. So this is the frame only, and here you can see the top pin. This is a cassette with a little slider. The slider goes into a hole here, and the top screw goes into this plastic part, so you can screw it up and down and adjust the height. The good thing about it is that we indeed can level the nozzle by sub-millimeter level, but there are some challenges that I will get into later. So this is the actual result of about a month or 2 months ago, where you can see like 2 cassettes next to each other. There's the 2 top screws there and there. It might be a bit fuzzy to see, but in the actual Ultimaker model that we have, it's standing over there. So if you want to take a look, it's in the other room to check and to take a look. This is the result of printing our first print with 2 components, PLA and PLA, so red and blue. It worked really well until about ½ centimeter printing, and then we started to get problems with the extrusion and the dripping. Dripping and extrusion were 2 problems that we encountered. We solved that more or less, but this is the first image, just to show you that not everything goes great at the first time, but if you try and adjust parameters, it gets better. But this is boring, right? It's PLA and PLA, everyone does it. This is slightly better. It's a bone, or a template from a bone, printed in PLA, polylactic acid, and here as a support material we use PVA, or polyvinyl acetate, which is a water-soluble biopolymer. So we print the bone with a little, well, it's a little bit bended, with a support material that can be dissolved, which enables us to make bridges that we can remove afterwards. The good thing about this is that we can also make like pores in squares. This is a square of PLA with like little wires. The white wires are PVA. Those wires we can dissolve in water, and then we should be able to put the cells or biomaterial in there at a later stage. So this is a bath of water with the PLA, PVA. And all these blocks look really nice. Again, this is one of the first pictures of how it started to look. A lot of oozing, dripping, messing around. This was supposed to be a square. But again, this is the first attempt. After a few days, we got to quite serious looking cubes. And yeah. Actually, it works quite well. Although there's still challenges, because what is a project if it's boring and everything works? So the frame cassette model has a few challenges. The height adjustment is improving, but it could get better because it's really paramount to get the height of the 2 cassettes really at the same position and not during printing that they shift. And what we have is that the cassettes, they make a little roll shift. The roll movement, we would like to block it. So if people have ideas about how to prevent it, have little tricks, it would be nice to talk to me afterwards and chat about that. The other thing that we would like to do is to miniaturize the cassette, which enables us to enlarge the print area, because The printer head is larger, so instead of the 20 by 20 square, we can only print 30 by 7 centimeters square at the moment. And we want to make things smaller. And we want to get rid of the fan, because the fan is it's really 5 by 5 centimeters. It's a big fan. We want to get the fan outside and use tubing to get wind or air cooling into the nozzles.
Maybe you take an aquarium pump.
Aquarium pump for the water.
Oh.
Yeah, that would be.
For the water, for the air.
Yeah.
It's pressurized air.
Yeah.
Pressurized air is.
Yeah. Yeah. The trick for the air is not so much the input, but it's to make the tubing such that the air is delivered to the correct nozzle, and with that the pressure drop or the pressure buildup is not an issue. So indeed, putting a pressure or a compressor is not an issue. So advice or suggestions about especially the height adjustments are really much appreciated. So talk to me or talk to Jelle if you would like to do. That was my talk. I would like to thank the people at Protospace, Jelle of course, who is the owner of this project, Wouter, Desiree, all the other employees and students, Ultimaker, because of course without an Ultimaker machine we had to refer to a MakerBot or another of the printers. And we try to work with open source software like design software, repositories to put all our source code on, things like that. So thanks for that as well. And I'm happy to take any questions if you have questions. Joris.
Thank you for this thought on your birthday.
Sure, thanks.
No problem. So why a cassette for the filament?
Sorry, why?
Why do you use a cassette for the print?
Instead of, well, if we want to use PLA or PVA or anything else that is a filament, then we could stick with this setup, with the current Ultimaker setup.
Yeah.
But we would like to put syringes or injection needles there, or we would like to have other grains or powder delivered to that. And if you want to modify the head, then it is difficult because you always have to open it or not. If you work with a frame cassette system, you can take out one cassette, modify it, and do all your adjustments, and then go back, put it on. Because what we want is not breaking down the Ultimaker all the time, which we did in the beginning. We want to get up to speed as much as possible with delivering the cells or the powder that we would like to have. And but if you have an idea about having this single head where we can attach stuff on, that would be perfect. Yeah. But think about toothpaste, for instance, consistencies like that. Can you print currently toothpaste with an Ultimaker? That is the type of material that we would like to work with. Yeah. Is there a question there?
So you have a nice cassette system. You can mount multiple cassettes, but did you also think about the modularity in the software and electronics? Because if you have multiple cassettes and you want, for instance, to use an extruder, maybe you have different temperature controllers locally, or you have different motors that you want to drive, like a DC motor, or maybe you even want to incorporate a printhead. Yeah. Did you think about it?
At the moment, we didn't. We worked on merging like G codes, like 2 G codes. Cura has a function that you can merge 2 or perhaps even 3. I'm not sure, but at least we use 2. Up to 4 you can merge up to 4. But we didn't look at 2 different temperatures, but I believe you can set the temperature for each extruder.
Yeah, but maybe you want more temperature zones, or you want a DC drive for some extruder, or...
Yeah, and then we have to think at what level we would like to have to. So I put firmware on the very beginning. It might be necessary to go to the firmware level and add extra codes that we don't have currently. But
maybe also go to the electronics level and look at the modularity at that level.
Yeah, that's good. That's for the next
version 5.
Exactly. Yeah.
I could imagine that you can save some of the weight, or at least the topple on the top, to see if you could just split it up. So you always have 2 fixed, maybe extruders going there, like the regular setup, and just 2 cassettes and balance them out on the X axis.
Yeah.
because I don't think you will ever do 4 cassettes which are not standard at the same time, because now you go to the maximum, you go to 4 cassettes.
Yeah.
So 4 spaces. So maybe you can save some weight by just doing 2 normal ones, and on the other side, diagonally 2 cassette versions.
Yeah. In the idea,
save some weight.
I'm not sure if weight is that much an issue, because the biggest weight is brought by the stepper motors, and they're outside or by the extruder heads.
Bring it.
Bring the forces out, the weight out, so it tumbles. And that's what you were talking about.
Well, the cassette is topping. Not the frame itself is sturdy, and you can use more bearings there.
Okay.
Now there's only one, but you can use 2 bearings and put them on the outside. That will solve it. The problem is with this cassette system that it's like wiggling a little bit, it's rolling a little bit.
Tolerance is a bit difficult for the cassette.
Yeah, and now we have a version 3 that Jelle made that is already more sturdy, more stable. But to get this, the frame itself is not so much an issue. Yeah.
In that case, you can combine the version 1 and this version, where you fix the cassette with the screws on the side, but you still use the top screw for the height adjustment. And once you have the height adjustment, you can just fix it.
Yeah.
And completely, because you don't want to change the height during build.
No.
So you can just.
At the moment, not yet. Yeah.
In the future, you may want to.
Might be too. Yeah. Really awesome, but
No, that's so much.
Are there any more questions?
I was thinking of one thing. Maybe you could use the fact that there's some possibility for it to roll, and you can also use that for adjusting it actually. So you could use some, I don't know, a very low friction part that you push against one of the rods to tilt it a little bit. Yeah. Might be a possibility because it simplifies the design. So something to try.
Yeah, cool.
Okay.
We'll talk later.
Yeah.
Thanks.
Okay, thanks again.